Hello there and welcome. I am so glad you are here tonight. Maybe today was long and tiring. Maybe your mind is full of thoughts that will not stop spinning. Or maybe you are the kind of person who likes to think about faraway planets and floating moons before you sleep instead of counting sheep or worrying about tomorrow. Whatever brought you here, this journey is for you. You do not need to do anything right now except rest. Let your breathing become slow and calm. Let your thoughts become softer and quieter. Let your body feel light, as if gravity has loosened its hold on you and you have started to float gently through space. Because tonight, we are going to drift slowly through the solar system together. We will not rush. We will not follow a straight line. Instead, we will move in soft spirals, visiting sunlit planets and dusty rings, shadowed craters and frozen oceans hidden beneath thick ice. This is a story told not in numbers and equations, but in magnetic storms and tilted axes, in moons that glow in the darkness, in sideways worlds where it rains diamonds, in ancient sunlight that is still crossing the empty void after millions of years. Every orbit around every star holds something strange and beautiful. We will go slowly and gently, just one sleepy fact at a time. Before we begin our journey, I want to say something. If these quiet explorations help you unwind at the end of your day, if they give you a peaceful way to let go of stress and worry, please consider gently tapping the like button and subscribing to the channel. It helps other people find their way here too, one sleepy soul at a time. But there is no pressure. You're welcome here whether you subscribe or not. Now let your eyes close if they want to. Let your body sink deeper into whatever is holding you. Let the world around you fade away. We are about to visit worlds where winds break the speed of sound, where canyons stretch across entire continents, where storms have raged for hundreds of years. We will see rings made of ice, volcanoes taller than mountains, and moons with their own moons. We will learn about planets that spin backward, oceans hidden under ice, and spacecraft that are still traveling through the darkness between stars. You do not need to remember any of this. You do not need to take notes or pay close attention. Just let the words wash over you like gentle waves. Let them carry you softly towards sleep. The universe is vast and patient, and tonight it is here to help you rest. So take a deep breath, let it out slowly, and let us begin. Fact 1. Neptune's winds break the speed of sound. Neptune is the farthest known planet from our Sun. It sits at the cold, dark edge of the solar system where sunlight is weak and distant. You might think that a planet so far from the Sun would be quiet and still, frozen into place by the cold. But Neptune is not still at all. In fact, it hosts the fastest winds in the entire solar system. These winds whip through the upper atmosphere at speeds that exceed 2,000 kilometers per hour. That is faster than the speed of sound here on Earth. It is roughly 5 times faster than a commercial airplane flying through our sky. Scientists believe these powerful winds get their energy from deep inside the planet. Even though Neptune is incredibly cold on the outside, it still has heat radiating outward from its interior. This internal warmth drives the violent motion in the atmosphere. The atmosphere itself is made mostly of hydrogen, helium, and methane gas. The methane gives Neptune its beautiful pale blue colour. The winds carve massive storm systems into the clouds, creating swirling patterns that stretch thousands of kilometers across the planet's surface. Neptune is a frozen world, but it is also a world in constant supersonic motion. Even in the coldest, darkest corners of the solar system, there is movement and energy and chaos. The winds never stop. They howl through the blue clouds endlessly, carrying storms that dwarf anything we have ever seen on Earth. It is a reminder that distance from the Sun does not always mean stillness. Sometimes it means wildness beyond imagination. Fact 2. Mars holds a canyon the size of a continent. If you were to stand on the surface of Mars and look out across the landscape, you might see rust-coloured dust stretching to the horizon. You might see ancient dry riverbeds and rocky hills. But if you were standing near the equator, you might also see something much more dramatic. You might see the edge of a canyon so vast and deep that it is hard to believe. This canyon is called Valles Marineris, and it is the largest canyon system in the entire solar system. It stretches more than 4,000 kilometers across the Martian equator. To put that in perspective, if you place this canyon on Earth, it would span the entire width of the continental United States from coast to coast. In some places, Valles Marineris plunges more than 7 kilometers deep into the planet's crust. That is more than 5 times deeper than the Grand Canyon. Scientists believe this enormous scar in the surface of Mars formed through a combination of tectonic stretching, volcanic activity, and erosion over billions of years. Unlike canyons on Earth, which are usually carved slowly by ravids cutting through rock, Valles Marineris may have opened up as the planet's crust cracked and pulled apart. Imagine the ground splitting open like dry Earth after a drought, but on a planetary scale, it is a wound in the surface of Mars, a hint of a violent geological past that is now frozen in time. The canyon sits silent and empty under the thin Martian atmosphere, a monument to forces that shaped the planet long ago. Fact 3. Venus has no magnetic field. Venus and Earth are often called sister planets because they are similar in size, mass, and composition. They are both rocky worlds with thick atmospheres, and they orbit relatively close to each other in the solar system. But despite these similarities, Venus lacks one crucial planetary feature that Earth has. It has no global magnetic field. Here on Earth, our magnetic field is generated deep inside the planet by the motion of molten iron in the outer core. This motion creates electric currents, which in turn produce a magnetic shield that surrounds the entire planet. This shield is incredibly important because it protects us from the solar wind, a constant stream of charged particles that flows out from the sun. Without this protection, the solar wind would gradually strip away our atmosphere and bombard the surface with harmful radiation. Venus, however, does not have this protection. Scientists believe that Venus has a sluggish or possibly solid core, which prevents the kind of dynamo effect needed to create a magnetic field. Without a magnetic shield, the atmosphere of Venus is constantly bombarded by solar wind. Over billions of years, this bombardment has stripped away lighter elements from the atmosphere. This may help explain why Venus, which might have once been more like Earth, became the furnace world it is today. The absence of a magnetic field has left Venus exposed and vulnerable, slowly losing pieces of itself to space. Fact 4. Diamonds may rain on Uranus and Neptune. Deep within the atmospheres of the icy giants Uranus and Neptune, something extraordinary may be happening. Conditions may be extreme enough to create falling diamonds. This sounds like science fiction, but scientists believe it may be real. Both Uranus and Neptune have thick layers of methane gas in their atmospheres. Deep below the visible cloud tops, the pressure becomes immense and the temperature rises dramatically. Under these extreme conditions, scientists believe the methane molecules can break apart, releasing carbon atoms. These carbon atoms are then compressed by the crushing pressure into crystalline structures, forming tiny diamonds. These diamonds would then rain down slowly toward the core of the planet, drifting through layers of gas and liquid. Laboratory experiments here on Earth have simulated this process. Researchers have shown how hydrocarbons, which are compounds made of hydrogen and carbon, can condense into diamond under the right conditions of heat and pressure. If this theory is correct, then storms of glittering crystals might be drifting through the deep blue darkness of these distant gas giants. Imagine a rain made not of water, but of precious gems, falling endlessly through an alien atmosphere. It is one of the most beautiful and strange possibilities in the entire solar system. Fact 5. Earth is the only planet with plate tectonics. One of the most distinctive and life-enabling features of Earth is its system of plate tectonics. This is a dynamic network of shifting crustal plates that float on top of the mantle, the hot semi-liquid layer beneath the crust. These moving plates create earthquakes when they grind against each other, build mountains when they collide, and recycle carbon dioxide through volcanic activity, which helps regulate the climate over geologic time. So far, no other planet in the solar system shows clear evidence of this process. Mars and Venus both have surface fractures and volcanic features, but they appear to be geologically stagnant by comparison. Their crusts do not move and shift the way Earth's crust does. This makes Earth unique. Plate tectonics may be part of what makes our planet habitable. The constant movement of the plates drives long-term cycles that stabilize temperature, support the existence of oceans, and enable the slow movement of continents over eons. It recycles nutrients, creates diverse landscapes, and may even play a role in the development and evolution of life. Without plate tectonics, Earth might be a very different place, perhaps more like Venus or Mars, but here the ground beneath our feet is always moving, always changing, always renewing itself in a slow dance that has been going on for billions of years. Fact 6. Some asteroids have their own moons. When we think of asteroids, we often picture solitary rocks tumbling through space, drifting alone through the asteroid belt between Mars and Jupiter. But some asteroids are not alone. They have their own moons, smaller bodies that orbit around them. These tiny satellites are usually captured fragments from collisions, or they are co-formed companions that were born alongside the asteroid itself. The first discovered asteroid moon was named Dactyl, and it orbits around an asteroid called Ida. This discovery was made by the Galileo spacecraft in 1993, and it surprised scientists. Since then, dozens more asteroid moon systems have been found scattered throughout the solar system. Some asteroids have multiple moons orbiting them, creating miniature systems that mirror the structure of planets and their satellites. In some cases, two asteroids of similar size orbit each other in a binary arrangement, neither one clearly the moon of the other. These systems show that even in the vastness of space, even among the smallest of objects, gravity can link things together into quiet, drifting partnerships. It is a reminder that the universe is full of companionship, even in the most unexpected places. Fact 7. Mercury has a ghostly exosphere. Instead of a true atmosphere unlike Earth, Mercury does not have a thick atmosphere to retain heat or scatter light. Instead, it has something much thinner and stranger. It has an exosphere, which is a near vacuum where atoms bounce around without colliding with each other. This exosphere is made of atoms that have been blasted from the surface of Mercury by solar wind and micrometeoroid impacts. These atoms include sodium, potassium, and oxygen, among others. Because Mercury has very weak gravity and is so close to the Sun, it cannot hold on to a real atmosphere. The particles constantly escape into space, drifting away into the void. But they are also constantly replenished from the surface as new impacts blast more material upward. The result is a ghostly, shimmering envelope of scattered atoms. It is invisible to the human eye, but it can be detected with the right instruments. It gives Mercury a faint glow when viewed in certain wavelengths of light. This exosphere changes constantly, shifting with the solar wind and the planet's position in its orbit. It is not a protective blanket like Earth's atmosphere. It is more like a faint breath, a whisper of gas that clings weakly to a scorched and battered world. Fact 8. The Sun loses millions of tons of mass every second. Every single second, the Sun converts over 4 million tons of its own mass into energy through nuclear fusion. This happens deep in the core, where the temperature and pressure are so extreme that hydrogen atoms are forced together to form helium atoms. This process releases enormous amounts of light and heat, which radiate outward in all directions, warming planets, driving winds, and fueling life on Earth. Though the loss of 4 million tons per second sounds like a lot, it is actually minuscule compared to the Sun's total mass. The Sun is so massive that it will continue burning steadily for billions of years before it exhausts its hydrogen fuel. Over that time, the cumulative loss will add up, but for now the Sun continues to shine with steady brilliance. This process of converting mass into energy is described by Einstein's famous equation, which shows that even a tiny amount of mass can produce a tremendous amount of energy. The Sun is constantly sacrificing a tiny part of itself with every passing second, turning matter into light and warmth. It is this self-sacrifice that makes life possible here on Earth, and it has been going on for over 4.5 billion years. Fact 9. Saturn's rings are slowly disappearing. The beautiful rings that encircle Saturn are one of the most iconic sights in the solar system. They shimmer and glitter in sunlight, stretching hundreds of thousands of kilometers across space. But these rings are not permanent. They are gradually falling into the planet, drawn inward by gravity and pulled down by Saturn's magnetic field. This process is known as ring rain. It involves streams of ice particles and charged material drifting inward over time, spiraling down toward the planet's atmosphere. Observations from the Cassini spacecraft, which orbited Saturn for 13 years, suggest that the rings may be less than 100 million years old. That is young by planetary standards. The same observations suggest that the rings could vanish entirely in another few 100 million years. Though the rings seem timeless when we look at them through telescopes, they are actually a temporary feature. They are a shimmering spectacle that will one day fade into memory. Future generations of beings, if they exist, may look at Saturn and see only a bare planet without its glorious adornment. For now, we are lucky to live in an era when Saturn still wears its crown of ice. Fact 10. Mars experiences planet-wide dust storms. Mars is known for its rusty, desert-like landscape. It is a cold, dry world with a thin atmosphere and no liquid water on the surface. But despite its barren appearance, Mars is not a quiet or inactive planet. It is home to colossal dust storms that can sometimes engulf the entire planet. These storms can last for weeks or even months at a time. They block out sunlight and reshape the surface with powerful winds. The dust on Mars is incredibly fine, much finer than sand on Earth. It can stay suspended in the thin atmosphere for long periods, creating a hazy, reddish glow that covers the sky. Some storms begin as small gusts, localized disturbances that kick up dust in a single region. But they can grow rapidly due to feedback loops between heat, wind, and topography. As the dust absorbs sunlight, it heats the air, which creates more wind, which kicks up more dust, and the cycle continues. In 2018, one of these planet-wide storms led to the end of the Opportunity rover's mission. The rover, which had been exploring Mars for over 14 years, was powered by solar panels. The dust storm was so thick and lasted so long that the solar panels were choked with dust and could not generate enough power. The rover fell silent and never woke up again. Even without rain or oceans, Mars remains an active and restless world shaped by the wind and dust that dance across its surface. Fact 11. Europa may have a salty ocean beneath its ice. Beneath the frozen shell of Jupiter's moon, Europa, there is strong evidence for a vast subsurface ocean of liquid water. This ocean is hidden beneath an icy crust that is several kilometers thick, sealed away from the vacuum of space. But it is there, warmed by tidal forces from Jupiter's immense gravity. Jupiter's gravity flexes Europa's interior as the moon orbits, generating heat through friction. This tidal heating may keep the ocean from freezing solid, despite the moon's distance from the sun. The surface of Europa is streaked with dark lines and ridges, signs of shifting ice and geological activity. Spacecraft have detected magnetic signatures and chemical traces that support the hypothesis of a hidden ocean. What makes Europa especially fascinating to scientists is the possibility that this ocean could harbour life. Water is essential for life as we know it, and Europa may have not just water, but also a source of heat and possibly chemical nutrients. It is a dark alien ocean warmed from below and sealed beneath ice, yet potentially rich with the ingredients necessary for biology. Future missions may one day drill through the ice or analyze plumes of water that erupt from the surface, searching for signs of life in this hidden sea. Fact 12. Mars has a volcano taller than Everest. On the surface of Mars stands the tallest volcano in the entire solar system. Its name is Olympus Mons, and it towers nearly 22 kilometers above the Martian plains. That is almost 3 times the height of Mount Everest, the tallest mountain on Earth. If you stood at the base of Olympus Mons and looked up, the summit would be far beyond the reach of your vision, lost in the thin Martian atmosphere. Olympus Mons is so wide that it would cover the entire state of New Mexico if placed on Earth. It is a shield volcano, which means it was formed by repeated eruptions of lava over millions of years. The lava flowed out gently and spread across a wide area, building up layer upon layer until the volcano grew to its enormous size. One reason Olympus Mons grew so large is that Mars lacks plate tectonics. On Earth, volcanic hotspots shift over time as the tectonic plates move. This creates chains of volcanic islands, like the Hawaiian Islands. But on Mars, the crust remained still. The volcanic hotspot stayed in one place, and magma erupted in the same location again and again, building a single massive structure. Today, Olympus Mons is dormant. It looms steadily over the Martian landscape, a monument to ancient volcanic fury. Fact 13. Saturn's rings are paper thin. Saturn's majestic rings stretch more than 280,000 kilometers across, making them one of the largest structures associated with any planet. Yet despite their enormous span, the rings are astonishingly thin. In most places, they are less than 100 meters thick. That is thinner than many city buildings here on Earth. The rings are made mostly of water ice. and the particles that make up the rings range in size from tiny grains of dust to boulders the size of houses. These countless fragments orbit Saturn in a flat disk, held in place by the planet's gravity and the self-organization of billions of icy pieces. The influence of small shepherd moons also helps maintain the structure of the rings, keeping them in narrow bands and preventing them from spreading out. When sunlight passes through the ring zone at certain angles, the rings nearly disappear from view. They become almost invisible, like a sheet of glass turned sideways. From a distance, the rings appear solid and substantial, but up close they are delicate and ethereal. They are a shimmering band of ice caught in motion, a temporary beauty that will one day fade away. Fact 14. Earth is the densest planet of all the planets in the solar system. Earth is the densest. This means it packs more mass into each cubic centimetre than any other planet. This high density is due to Earth's composition, which includes a metal-rich iron core and a silicate mantle made of rock. Earth's density is about 5.5 grams per cubic centimetre, which is higher than that of Jupiter, despite the gas giant's far greater size. This density plays a key role in generating Earth's magnetic field. The movement of molten iron in the outer core creates electric currents, which produce the magnetic shield that protects our planet from harmful solar radiation. Our planet's internal structure is compact, heavy, and layered. The core is surrounded by the mantle, which is in turn covered by the thin crust on which we live. This dense, tightly packed structure shapes not just Earth's gravity, but also its geology, its magnetic field, and its ability to support life. In a solar system full of gas giants and icy worlds, Earth stands out as a small but incredibly dense and dynamic planet. Fact 15. The sun vibrates like a musical instrument. Though we cannot hear it with our ears, the sun constantly rings with pressure waves that ripple through its blazing layers. These oscillations are caused by rising and falling currents of plasma deep within the sun. They generate ultra-low frequency sounds, far below the range of human hearing. Scientists study these vibrations through a technique called helioseismology. By tracking how the waves travel and bounce within the sun's body, researchers can map its internal structure. It is similar to the way geologists use seismic waves from earthquakes to explore Earth's interior. The sun's vibrations reveal hidden flows of gas, magnetic activity, and the dynamics of nuclear fusion deep within the core. In a way, the sun is always humming. It sings a silent song that reveals its secrets through vibration and rhythm. These oscillations tell us about the temperature, density, and rotation of different layers inside the sun. They help us understand how the sun works, how it generates energy, and how it will evolve over the billions of years. The sun is not just a ball of fire, it is a living, breathing, vibrating star. Factor 16. Venus rotates backward. Unlike most planets in the solar system, Venus spins in the opposite direction. This phenomenon is known as retrograde rotation. On Venus, the sun rises in the west and sets in the east, the reverse of what we experience on Earth. Even stranger, Venus rotates incredibly slowly. A single day on Venus, the time it takes for the planet to spin once on its axis, lasts 243 Earth days. Meanwhile, it only takes Venus 225 Earth days to complete one orbit around the Sun. That means a day on Venus is actually longer than a year on Venus. Scientists are not entirely certain why this happened. One possibility is that Venus experienced a massive collision early in its history, an impact so powerful that it altered the planet's spin. Another theory suggests that tidal interactions with the Sun slowly flipped Venus's axis over billions of years. Whatever the cause, Venus stands alone as a slow-turning world with a reversed rhythm. It is a planet that defies the normal rules, spinning backward through space at a pace so slow it is almost imperceptible. Fact 17. Jupiter has more than 90 moons. The gas giant Jupiter is not just the largest planet in the solar system, it is also the king of moons. As of now, astronomers have identified over 90 natural satellites orbiting Jupiter, and new ones are still being discovered as telescope technology improves. The 4 largest moons are known as the Galilean moons, named after Galileo Galilei, who first observed them through a telescope in 1610. These moons are Io, Europa, Ganymede, and Callisto. They are large enough to be considered worlds in their own right, But beyond these giants lies a swarm of smaller irregular moons. Many of them are just a few kilometers across. Some orbit backward, moving in the opposite direction of Jupiter's rotation. These tiny moons may have been captured from the asteroid belt or the Kuiper Belt, or pulled in by Jupiter's immense gravity. Together, all these moons form a miniature solar system in orbit around Jupiter. They are bound by the planet's gravity and shaped by its history. Some are icy, some are rocky, some are volcanically active, and some are completely dead. They represent a diverse family of worlds, each with its own story, all circling the giant planet in a cosmic dance that has been going on for billions of years. Fact 18. Mercury hides, ice in its shadows. Mercury is the closest planet to the Sun, and during the day, its surface temperature can soar to over 400 degrees Celsius. At night, temperatures plunge far below freezing. It is a world of extremes, scorching during the day and freezing in the darkness. You would not expect to find ice on such a planet, yet it is there. At Mercury's poles, deep inside craters that never receive sunlight, temperatures remain cold enough for water ice to exist. These permanently shadowed regions act like natural freezers, preserving ice for millions of years. The crater walls block the sunlight completely, keeping the interior in eternal darkness and cold. Radar reflections from spacecraft like Messenger have confirmed the presence of these bright icy patches. Scientists believe the water may have arrived from comet impacts long ago, or it may have been released by ancient volcanic outgassing. In the heart of one of the hottest planets in the solar system, ice survives, locked in darkness and shielded from the relentless solar blaze. It is a reminder that even in the most extreme environments, pockets of the unexpected can persist. Fact 19. Pluto's heart may hide an ocean. One of the most striking features on Pluto is a large, bright, heart-shaped region known as Sputnik Planitia. This formation is not just a scenic landmark, it may be the surface expression of a vast underground ocean hidden beneath the ice. Though Pluto is far from the Sun and cold enough to freeze nitrogen, evidence from the New Horizons spacecraft suggests that a layer of liquid water might lie beneath the icy crust. The weight of the heart-shaped basin and its apparent geological activity hint at a slushy, convecting subsurface. If this ocean exists, it could be kept liquid by heat from radioactive decay deep within Pluto's core, combined with insulating layers of ice above that trap the warmth. Even in the frozen reaches beyond Neptune, billions of kilometers from the Sun, a hidden sea may quietly persist beneath the surface. Pluto may be small and distant, but it is not as dead as it appears. There may be liquid water beneath its frozen heart, a secret ocean that has been hidden away for billions of years. Fact 20. The asteroid belt is mostly empty space. Despite what popular imagination and science fiction movies might suggest, flying through the asteroid belt would not be like dodging rocks in a chaotic obstacle course. In reality, the asteroid belt is vast and sparsely populated. The asteroids are separated by enormous distances. Spacecraft passing through would almost never encounter an obstacle. The asteroid belt is located between the orbits of Mars and Jupiter. It contains millions of rocky bodies, ranging from tiny pebbles to large objects hundreds of kilometers across. But even with millions of asteroids, the total mass of the entire asteroid belt is less than 5% of the mass of Earth's moon. Most of that mass is concentrated in just a few large objects like Ceres and Vesta. The rest are scattered fragments from the early solar system, ancient building blocks that never coalesced into a planet. If you were to travel through the asteroid belt, you would see mostly empty black space. Occasionally a distant rock might drift by far away and barely visible. The asteroid belt is not a crowded highway. It is a quiet, lonely region where ancient debris slowly orbits the Sun in chance. Fact 21. Uranus rolls around the Sun. Most planets spin like tops, tilted slightly on their axis as they orbit the Sun. But Uranus is different. It is tipped so far over at them that it essentially rolls along its orbital path. Its axial tilt is 98 degrees, which means its poles point almost directly at the Sun during parts of its orbit. This extreme tilt gives Uranus bizarre and extreme seasons. Each pole experiences 42 years of continuous daylight, followed by 42 years of continuous darkness. Imagine a summer that lasts for decades, where the Sun never sets, followed by a winter of equal length where the Sun never rises. The cause of this unusual tilt is still debated among scientists. The most likely explanation is that Uranus was knocked sideways by a massive collision with another large body early in the history of the solar system. This impact may have tipped the planet on its side and left it rolling through space ever since. Uranus's tilted orientation gives it one of the strangest climates in the solar system, a world where the seasons are measured not in months, but in decades. Fact 22. Jupiter's radiation belts are deadly. Jupiter is surrounded by a massive magnetic field, the strongest of any planet in the solar system. Within this magnetic field are radiation belts filled with charged particles trapped by the planet's magnetism. These radiation belts are so intense that they would destroy unprotected spacecraft in a matter of hours. The belts are similar in structure to Earth's Van Allen belts, but they are vastly more powerful. The radiation is so strong that it can damage electronic equipment and pose a serious hazard to any future missions that attempt to orbit Jupiter or land on its moons. Even Jupiter's largest moons are exposed to this radiation, which affects their surfaces and may complicate the search for life. To survive in orbit around Jupiter, spacecraft must be equipped with special shielding, or must follow trajectories that keep them in lower radiation paths. It is a beautiful and majestic world, but it is also one wrapped in invisible danger. The radiation belts are a reminder that Jupiter is not just a giant planet. It is a hostile environment where the forces of magnetism and charged particles create deadly zones in space. Fact 23. The Sun contains nearly all the mass in the solar system. At the heart of our solar system sits the Sun, dominating not just with its light and heat, but with its sheer mass. The Sun holds over 99.8% of all the mass in the entire solar system. That means everything else, all the planets, all the moons, all the asteroids, all the comets and all the dust, makes up less than 1/4%. This immense mass is what gives the Sun its powerful gravitational pull. It is this gravity that binds everything in orbit, from the tiny grains of dust in the asteroid belt to the distant comets in the Oort cloud, billions of kilometers away. The Sun's gravity holds the solar system together, keeping the planets in their paths and preventing them from flying off into the void. This massive concentration of matter is also what fuels the nuclear fusion reactions at the Sun's core. The intense pressure created by the Sun's own weight compresses hydrogen atoms until they fuse into helium, releasing the energy that floods space with light and warmth. The Sun is not just the center of the solar system, it is the solar system in terms of mass and gravity and energy. Fact 24. There are more dwarf planets than classical planets. Beyond Neptune lies a scattered population of icy, distant objects. Many of these objects are large enough to qualify as dwarf planets, a category of celestial bodies that are round like planets but have not cleared their orbital paths of other debris. Pluto is the most famous dwarf planet, but it is just one among many. Others include Eris, Haumea, Makemake and Ceres. More candidates are constantly being discovered in the Kuiper Belt and beyond, in the distant reaches of the solar system where sunlight is faint and temperatures are close to absolute zero. In fact, the number of dwarf planets may vastly exceed the number of classical planets. There are only 8 classical planets, but there could be dozens or even hundreds of dwarf planets scattered throughout the outer solar system. These small round worlds are relics of the early solar system. They are untouched and ancient, preserving clues about the materials and processes that built everything we know. Though they orbit in the cold shadows far from the Sun, they hold secrets about the birth of the solar system. Fact 25. A day on Venus lasts longer than its year. Venus has one of the slowest rotations of any planet in the solar system. It takes 243 Earth days for Venus to complete a single rotation on its axis. Meanwhile, it only takes 225 Earth days for Venus to complete one orbit around the Sun. This means that a single day on Venus, measured from one sunrise to the next, is actually longer than a full year on Venus. If you were standing on the surface of Venus and watching the sky, you would see the Sun move incredibly slowly across the horizon. It would take months for the Sun to cross from one side of the sky to the other. This sluggish rotation also contributes to the extreme surface conditions on Venus. Without a rapid day-night cycle, the planet does not experience the kind of temperature variation that other planets do. Instead, the entire surface remains at a constant searing temperature, hot enough to melt lead. Combined with its thick acidic atmosphere and crushing pressure, Venus is a world of slow, simmering heat and eerie, sunless days that stretch on for months. Fact 26. Titan has lakes made of methane. Saturn's largest moon, Titan, is the only other place in the solar system known to have stable liquids on its surface. But these are not lakes of water. Instead, Titan's lakes and rivers consist of liquid methane and ethane, flowing across a landscape sculpted by cold chemistry rather than warm biology. Titan has a thick atmosphere rich in nitrogen similar in pressure to Earth's atmosphere at sea level. This atmosphere forms weather systems that include methane rain and even seasonal storms. Clouds gather and drift across the orange sky, releasing droplets of methane that fall to the surface and collect in vast bodies of liquid. Some of Titan's lakes are enormous, stretching hundreds of kilometers across their frozen shores. Beneath the icy surface, scientists believe a subsurface ocean of water may also exist, hidden far below the methane lakes. This would make Titan a world with two completely separate liquid systems, one on the surface made of hydrocarbons, and one deep underground made of water. Titan is a world with familiar shapes and processes, clouds and rivers and coastlines, but they are all built from alien substances that would be impossible on Earth. Fact 27. The moons of Mars may be captured. Asteroids. Mars has two tiny misshapen moons named Phobos and Deimos. They look more like asteroids than traditional moons. They are irregular, rocky and covered with impact craters. Their surfaces are dark and dusty, and they tumble through space in odd, uneven orbits around the red planet. Many scientists believe these moons were once part of the asteroid belt, drifting between Mars and Jupiter. At some point in the distant past, they may have wandered too close to Mars and were captured by the planet's gravity. Their strange orbits and low densities support this theory, though some alternative explanations suggest they may have formed from debris after a massive impact on Mars itself. Phobos, the larger of the two moons, is slowly spiraling inward toward Mars. In about 50 million years, it will either break apart from tidal forces or crash into the planet's surface. Deimos, on the other hand, is drifting farther away. These little moons are quiet passengers in orbit, remnants of a chaotic past, slowly moving toward different fates as they circle the red planet. Factor 28. Jupiter glows with its own heat. Unlike most planets, Jupiter gives off more energy than it receives from the Sun. This internal glow comes from leftover heat from the planet's formation billions of years ago. When Jupiter first came together from the swirling cloud of gas and dust that formed the solar system, its immense mass collapsed under its own gravity. This collapse generated tremendous heat, and that heat is still radiating outward today. Over time, Jupiter continues to contract very slightly, releasing gravitational energy in the form of warmth. This internal heat drives the planet's turbulent weather system, including its giant storms and swirling bands of coloured clouds. In the infrared spectrum, which detects heat rather than visible light, Jupiter shines brightly, like a smouldering coal beneath layers of cloud. Jupiter is not a star, and it never became one. If it had been just a bit more massive, perhaps 80 times its current size, the pressure and temperature in its core would have been high enough to ignite nuclear fusion. But it fell short of that threshold. Instead, it remains a failed star, a giant planet that glows with fading warmth from its birth. Fact 29. Neptune was discovered through math. Unlike the other planets, Neptune was not discovered by simply looking through a telescope and spotting it among the stars. Instead, it was found through mathematics and careful observation of another planet's behaviour. In the 1840s, astronomers noticed something strange about the orbit of Uranus. The planet was not moving exactly as it should according to the known laws of gravity. There were tiny deviations, small irregularities that could not be explained by the gravitational pull of the Sun and the other known planets. Two mathematicians working independently in different countries used these strange motions to predict the location of a hidden planet. They calculated where this unseen world must be in order to cause the observed effects on Uranus. When astronomers pointed their telescopes toward the predicted position, Neptune was there, exactly where the math said it would be. It was a triumph of celestial mechanics, a confirmation that unseen forces could be mapped and predicted through equations alone. Neptune was the first planet found on paper before it was seen through glass, a world brought to light by the numbers and careful reasoning. Fact 30. Saturn's north pole has a hexagon. At Saturn's north pole, a massive cloud pattern spins in the shape of a nearly perfect hexagon. This six-sided jet stream spans over 30,000 kilometers across, wider than the entire diameter of Earth. It has persisted for decades and possibly for centuries without changing its shape or breaking apart. Scientists believe the hexagon forms from the way Saturn's atmosphere rotates and interacts with stable waves of air trapped around the pole. Different layers of the atmosphere move at different speeds, creating patterns of turbulence. In laboratory experiments here on Earth, researchers have created similar hexagonal shapes by rotating fluids at varying speeds in cylindrical containers. The fact that such a geometric shape can emerge naturally in a planetary atmosphere is one of the more surreal and elegant phenomena in the solar system. It looks almost artificial, as if someone drew it with a ruler and compass, but it is entirely natural, a product of physics and fluid dynamics playing out on a planetary scale. The hexagon remains one of Saturn's most mysterious and beautiful features. Fact 31. The Sun's atmosphere is hotter than its surface. It might seem logical that the hottest part of the Sun would be at its core, where nuclear fusion takes place, and that temperatures would decrease as you move outward. The core is indeed the hottest region, with temperatures exceeding 15 million degrees. The visible surface, called the photosphere, cools down to about 5,500 degrees. But then something strange happens. As you move farther out from the surface into the Sun's outer atmosphere, known as the corona, the temperature suddenly rises again. The corona can reach temperatures of over 1 million degrees, far hotter than the surface below it. This unexpected increase in temperature has puzzled scientists for decades. One theory suggests that magnetic waves from deep within the Sun transfer energy upward, heating the corona from below. Another possibility involves tiny solar explosions called nanoflares, which might constantly pump energy into the outer atmosphere. Either way, the Sun's outer layers glow with mysterious searing heat that defies simple explanation. Fact 32. The Kuiper Belt is full of icy worlds beyond. Neptune lies a wide ring of icy objects known as the Kuiper Belt. It stretches billions of kilometers from the Sun and is home to countless frozen bodies including Pluto, Eris, Haumea, and Makemake. These are not stars or planets in the traditional sense, but ancient remnants from the solar system's formation. Some of these objects are spherical and large enough to be classified as dwarf planets. Others are irregular chunks of ice and rock tumbling through space without any particular shape. The Kuiper Belt is similar in structure to the asteroid belt, but it is much farther from the Sun, much colder, and contains more primordial ice than rock. This region is a fossil zone, a frozen archive of the materials that built the outer worlds billions of years ago. By studying objects in the Kuiper Belt, scientists can learn about the conditions and chemistry of the early solar system before the planets had fully formed. It is a window into the past, preserved by the cold and distance from the Sun. Fact 33. The Oort cloud may stretch a light year from the Sun. Far beyond the Kuiper Belt, even beyond Pluto's most distant reach, lies a hypothetical shell of icy bodies known as the Oort cloud. Though it has never been directly observed, astronomers believe this vast sphere of frozen debris encircles the entire solar system and extends nearly 1 light-year away from the Sun. The Oort cloud is thought to be the birthplace of long-period comets, those icy visitors that appear from the depths of space with unpredictable orbits. These comets may have been dislodged from their resting places by the gravitational tug of passing stars or by subtle shifts in the galactic tide. When they fall inward toward the Sun, they can light up with spectacular glowing tails, visible even from Earth. If the Oort cloud exists as scientists believe, it marks the true edge of the Sun's gravitational influence. It is a distant halo of icy wanderers, barely clinging to the Sun's gravity, drifting in the cold darkness between our solar system and the nearest stars. Fact 34. Io is the most volcanic world in the solar system. Jupiter's moon. Io is a seething, restless world covered in active volcanoes. Its surface is constantly being reshaped by eruptions of molten sulfur and rock, painting the landscape in vivid yellows, reds, and blacks. Some volcanic plumes rise hundreds of kilometers into space, creating towering fountains of material that arc above the surface before falling back down. This extreme volcanic activity is driven by tidal heating. Io is squeezed and stretched by Jupiter's immense gravity, and this constant flexing generates friction deep within the Moon's interior. The neighbouring moons, Europa and Ganymede, also exert gravitational tugs on Io, creating a complex dance of forces that keeps the interior molten. Unlike Earth, where volcanic activity has slowed over billions of years as the planet cools, Io's surface is young and constantly renewed. There are no ancient craters on Io because any impact scars are quickly buried under fresh lava flows. It is a lava-lit moon with a molten heart, one of the most geologically active bodies in the entire solar system. Fact 35. Triton orbits backward, around Neptune. Triton, Neptune's largest moon, is unique among large moons because it orbits its planet in the opposite direction of Neptune's rotation. This backward motion is called a retrograde orbit, and it is extremely unusual for a moon of Triton's size. This strange orbit strongly suggests that Triton did not form alongside Neptune. Instead, it was likely captured from the Kuiper Belt, a region of icy objects beyond Neptune's orbit. When Triton was pulled into orbit by Neptune's gravity, the capture event may have been violent and chaotic. It could have disrupted or destroyed Neptune's original satellite system, scattering smaller moons and altering the structure of the entire system. Today, Triton is geologically active, with cryovolcanoes that spew icy material into space and a thin atmosphere that shifts with the seasons. Its surface is marked by strange textures and features unlike anything seen elsewhere. Cold, distant, and moving in reverse, Triton is a world that defies expectations at every turn. Fact 36. Earth's moon is unusually large. Compared to the size of its host planet, Earth's moon is enormous. No other rocky planet in the solar system has such a relatively large satellite. The moon is about 1/4 the diameter of Earth, a ratio that is more typical of dwarf planet-moon systems than of full-sized planets. Most scientists believe the moon formed after a catastrophic collision. About 4.5 billion years ago, a Mars-sized ghost body smashed into the young Earth. The impact was so violent that it ejected massive amounts of debris into orbit. Over time, this debris coalesced and condensed, eventually forming the moon. This close partnership between Earth and its moon has profoundly influenced our planet's development. The moon creates tides in the oceans, which may have played a role in the evolution of life. It stabilizes Earth's axial tilt, which helps regulate the climate, and it slows Earth's rotation through tidal friction, gradually lengthening our days. Our moon is not just a companion in the sky, it is a cosmic legacy of planetary collision and renewal. Fact 37. Planetary orbits are not perfect circles. Although we often imagine the planets moving in perfect circular paths around the Sun, their orbits are actually ellipses. An ellipse is a stretched circle, slightly elongated rather than perfectly round. The Sun is not at the centre of these ellipses, but at one of the two focal points, slightly offset from the middle. This elliptical shape means that each planet has a point in its orbit where it is closest to the Sun called perihelion, and a point where it is farthest called aphelion. For most planets, the difference between these two distances is subtle. Earth's orbit, for example, is nearly circular. But for others, like Mercury and Pluto, the difference is much more dramatic. Mercury's distance from the Sun varies significantly throughout its year, affecting how much sunlight and heat it receives. These variations influence seasons, solar radiation, and orbital speed. Planets move faster when they are closer to the Sun and slower when they are farther away. The elliptical nature of planetary motion was first described by Johannes Kepler in the 1600s, fundamentally reshaping our understanding of the solar system's elegant mechanics. Fact 38. Some comets come from the edge of interstellar space. Long-period comets, the kind that appear only once every few thousand years, are believed to originate from the Oort cloud, a distant shell of icy debris that may lie nearly a light-year from the Sun. These comets travel on elongated, loosely bound orbits, spending most of their time in the cold darkness far beyond the planets. They are often dislodged from their resting places by the gravitational influence of passing stars, or by subtle shifts in the galactic tide as the solar system moves through the Milky Way. When a comet is nudged inward, it begins a long fall toward the Sun, accelerating as it approaches. As it nears the inner solar system, the Sun's heat causes the icy surface to sublimate, releasing gas and dust that form a glowing tail. Some of these comets may have spent billions of years drifting in darkness before being disturbed. Their bright returns are fleeting glimpses of the solar system's most ancient untouched matter, visitors from the very edge of the Sun's gravitational reach. Fact 39. The Sun will become a white dwarf. The Sun, like all stars, has a finite lifetime. In about 5 billion years, it will exhaust the hydrogen fuel in its core and begin to change. When the core runs out of hydrogen, the Sun will start fusing helium into heavier elements. This process will cause the outer layers to expand dramatically, turning the Sun into a red giant. During this phase, it may grow large enough to engulf Mercury, Venus, and possibly even Earth. After shedding its outer layers in a glowing shell of gas called a planetary nebula, the core that remains will become a white dwarf. This is a dense, Earth-sized remnant made mostly of carbon and oxygen. A white dwarf no longer produces energy through fusion. It simply radiates away its remaining heat over trillions of years, slowly cooling and fading. Eventually, the white dwarf that was once our Sun will become a cold, dark cinder, drifting through space as a black dwarf. But that final stage will take far longer than the current age of the universe. For now, the Sun continues to burn steadily, with billions of years of light and warmth still ahead. Fact 40. Mars has seasons like Earth. Though Mars is colder and has a much thinner atmosphere than Earth, it experiences seasons much like our own planet. This is because Mars has a similar axial tilt, about 25 degrees compared to Earth's 23. As Mars orbits the Sun, this tilt causes different hemispheres to receive more or less direct sunlight at different times of year. The result is a cycle of spring, summer, autumn and winter, with varying temperatures and patterns of light. Martian seasons also influence the polar ice caps, which grow and shrink with the changing temperatures. Dust storms become more frequent during certain seasons, and air pressure shifts slightly, as carbon dioxide freezes out of the atmosphere at the poles during winter. However, Martian seasons unfold more slowly than on Earth because Mars takes nearly twice as long to complete one orbit around the Sun. A single Martian year lasts about 687 Earth days, so while the rhythm of the seasons is similar, they stretch out over a much longer period. Fact 41. Ganymede is the largest moon in the solar system. Jupiter's moon. Ganymede holds the title of the largest natural satellite in the solar system. It is even bigger than the planet Mercury, with a diameter of over 5,000 kilometers. Ganymede has a rocky core, a possible subsurface ocean, and a crust covered in ridged ice and ancient impact scars. Uniquely, Ganymede is the only moon known to have its own magnetic field. This creates shimmering auroras in the thin atmosphere near its poles, faint glows of light caused by charged particles interacting with the magnetic field. Scientists believe Ganymede may have multiple layers of ocean sandwiched between sheets of ice deep below the surface, forming a complex internal structure unlike anything else. Despite its size and geological richness, Ganymede remains a quiet, dark world. It orbits deep within Jupiter's powerful magnetic field, exposed to intense radiation. Its surface is ancient and heavily cratered in some regions, while other areas show signs of more recent geological activity. Ganymede is a world of contrasts, large and complex, yet silent and still. Fact 42. Pluto. Sometimes orbits closer to the Sun than Neptune. Although Pluto is usually considered the most distant of the classical or dwarf planets, its orbit is highly elliptical. This means it does not follow a circular path, but instead stretches out in an elongated loop. At certain points in its orbit, Pluto actually travels closer to the Sun than Neptune does. This last occurred between 1979 and 1999, a period of about 20 years when Pluto was temporarily the 8th planet from the Sun instead of the 9th. Even during this time, however, the two worlds never came close to colliding or even approaching each other. Their orbits are in resonance, a gravitational relationship that keeps them in a stable dance. For every 3 orbits Neptune makes around the Sun, Pluto completes exactly 2. This mathematical relationship ensures that their paths never cross, even though they swap positions in terms of distance from the Sun. It is a delicate balance governed by celestial rhythm and gravitational harmony, a dance that has been going on for billions of years. Fact 43. The Sun reverses its magnetic field. Every 11 years. Roughly every 11 Earth years, something remarkable happens to the Sun. its magnetic field flips. The north and south magnetic poles switch places, reversing their polarity completely. This process, known as the solar magnetic cycle, is tied to the internal dynamics of the Sun and affects solar activity throughout the entire solar system. At the peak of the cycle, called solar maximum, the Sun becomes more active. Sunspots appear more frequently, solar flares erupt more often, and coronal mass ejections send bursts of charged particles streaming into space. During solar minimum, the Sun is quieter. With fewer sunspots and less intense magnetic activity, these cycles influence space weather throughout the solar system. They affect Earth's upper atmosphere, disrupt satellite communications, and create beautiful auroras near the poles. The Sun's magnetism is not fixed or permanent. It pulses and flows like a breathing magnetic heartbeat, constantly changing and renewing itself. Fact 44. Planetary alignments don't cause natural disasters. It is a common myth that planetary alignments can trigger earthquakes, floods, or other major disasters on Earth. But there is no scientific evidence to support this idea. The gravitational pull of other planets on Earth is extremely small, far weaker than the influence of the Moon or the Sun. Even during rare alignments, when several planets line up in the sky, their combined gravitational effect on Earth is negligible. The Moon, being so close to us, has a far greater impact on tides and seismic stress than massive but distant planets like Jupiter or Saturn. The forces involved are simply too weak to trigger geological events. Planetary alignments are beautiful and mathematically interesting, but they are gravitationally harmless. They represent a silent dance of distant worlds, not a celestial omen or a source of danger. The myths persist because humans have always looked to the sky for meaning, but the science is clear. The planets do not control our fate. Fact 45. Leaving the solar system takes decades escaping. The gravitational pull of the Sun is no small task. Even travelling at incredible speeds takes spacecraft many decades to reach the boundary where the Sun's influence fades and interstellar space begins. Voyager 1 and Voyager 2, launched in the 1970s, have only recently entered interstellar space after more than 40 years of continuous travel. They move at speeds exceeding 60,000 km per hour, faster than any other human-made objects. Yet even at these speeds, it took them over 4 decades to cross the heliosphere, the region where the solar wind gives way to the interstellar medium. These missions have crossed the orbits of all the planets, passed through the Kuiper Belt, and continued into the darkness beyond. They carry instruments that are still functioning, as well as golden records filled with sounds and images of Earth. They are our quiet ambassadors to the galaxy, drifting farther from home with every passing second. Fact 46. Earth's magnetic field shields us from space radiation. Surrounding our planet is an invisible magnetic field generated by the movement of molten iron in Earth's outer core. This magnetic field extends far out into space, creating a protective bubble around the planet known as the magnetosphere. This shield is incredibly important. It deflects charged particles from the Sun, preventing them from stripping away our atmosphere and bombarding the surface with harmful radiation. Without this protection, the solar wind would gradually erode our atmosphere, much as it likely did on Mars billions of years ago. The magnetic field also funnels some particles toward the poles, where they interact with gases in the upper atmosphere. This interaction produces auroras, shimmering curtains of green, red, and violet light that dance across the night sky. Earth's magnetosphere is a dynamic, constantly shifting shield, essential for preserving both life and climate over geological time. Fact 47. The Moon is slowly moving away from Earth. Each year, the Moon drifts about 3.8 centimeters farther from Earth. This slow retreat is caused by tidal interactions between the two bodies. The gravitational pull between Earth and the Moon creates bulges in our planet's oceans. These tidal bulges, in turn, exert a force on the Moon that gradually pushes it outward. In the distant past, the Moon was much closer to Earth than it is now. It appeared significantly larger in the sky, and its gravitational pull created much stronger tides. As the Moon recedes, our days gradually lengthen because the Moon's gravity also slows Earth's rotation through tidal friction. Billions of years from now, the Moon's orbit will be so wide that total solar eclipses will no longer be possible. The Moon will appear too small in the sky to fully cover the Sun. The celestial alignment that creates these spectacular events is temporary, a fortunate accident of timing that will not last forever. Fact 48. The Kuiper Belt holds icy worlds with mirrored surfaces, far beyond Neptune. The Kuiper Belt contains not only dwarf planets but also smaller icy bodies with startlingly bright surfaces. One example is Haumea, a fast-spinning, football-shaped object coated in crystalline water ice. Its rapid rotation, completing one spin every 4 hours, has stretched it into an elongated shape. Another example is Eris, which reflects nearly all the sunlight that hits it. It is one of the most reflective bodies in the solar system, brighter than freshly fallen snow. Scientists believe these objects may have been resurfaced by cryovolcanism, where icy material erupts from the interior and coats the surface. Impacts and chemical interactions may also play a role. In the darkness at the edge of the sun's reach, some of these distant worlds gleam like cold mirrors. They catch faint sunlight in their frozen surfaces and reflect it back into space, shining quietly in the cold. Fact 49. Enceladus sprays water. Into space Saturn's tiny moon. Enceladus may be small, but it hides a spectacular secret beneath its icy surface. From the south pole of the moon, towering geysers of water vapor and ice crystals erupt into space through long cracks known as tiger stripes. These plumes are powered by tidal heating beneath the surface. As Enceladus orbits Saturn, the planet's gravitational pull creates friction deep within the moon's interior. This friction generates heat, keeping a subsurface ocean in a liquid state despite the frigid temperatures at the surface. The water from this hidden ocean finds its way through cracks in the ice and erupts into space in spectacular fountains. The material in the plumes contains organic compounds, salts, and even signs of hydrothermal activity, raising the possibility that life could exist in the ocean below. Some of the water escapes into space and helps replenish Saturn's E-ring, a faint band of icy particles that encircles the planet. Enceladus creates a living connection between moon and planet, continuously spraying material into the void. Fact 50. Some asteroids are just piles of rubble. Not all asteroids are solid rocks. Many are loose collections of stones, gravel, and dust held together only by their own weak gravity. These fragile structures are known as rubble piles. Rubble pile asteroids can form after collisions shatter larger asteroids. The debris from the impact slowly drifts back together over time, clustering into a loose aggregate rather than a solid mass. These asteroids can have large internal voids and empty spaces. They can spin in strange ways, and they can change shape under pressure or external forces. Missions like Hayabusa 2 and OSIRIS-REx have visited such bodies and confirmed their delicate, porous nature. When spacecraft touched down on these asteroids to collect samples, they sank into the surface rather than landing on solid rock. These asteroids are not monolithic relics of the early solar system. They are chaotic assemblages, ancient drifting ruins that barely hold themselves together as they orbit the Sun. Fact 51. Mercury's core is disproportionately large. Mercury is a small planet barely larger than Earth's moon, but beneath its thin rocky crust lies an unusually massive iron core. This metallic center makes up about 80% of the planet's radius, a far larger proportion than what we see in Earth or Venus. The reason for this oversized core remains uncertain. Some scientists think Mercury once had a thick rocky mantle that was stripped away by a giant impact early in the solar system's history. The collision may have blown off much of the lighter material, leaving behind the dense iron core. Others believe Mercury formed very close to the Sun, where conditions favoured the accumulation of heavier elements over lighter ones. The result is a planet with a thin crust covering a huge metallic heart. Mercury also has a weak magnetic field, which is surprising given its large iron core. This suggests that the core may be partially solid, or that it rotates too solely to generate a strong dynamo effect. Mercury is a metal-heavy survivor from the solar system's chaotic youth. Fact 52. Venus has no moons at all. Among the rocky planets, only Mercury and Venus lack natural satellites. While Mercury's proximity to the Sun may explain its moonless state, Venus's situation is more puzzling. Venus is roughly the same size as Earth, which has a large moon, yet Venus orbits completely alone. Some theories suggest Venus may have once had a moon that fell back into the planet or was lost during a collision. Others argue that Venus is slow, so retrograde rotation might prevent stable lunar orbits from forming. The gravitational environment around Venus could make it difficult for a moon to remain in orbit over long periods. Whatever the cause, Venus drifts through space without a lunar companion. It has no satellite to create tides, no nearby body to stabilize its rotation. Venus orbits alone beneath its thick blanket of clouds, a bright, cloud-wrapped world with no moon to share its twilight sky. Fact 53. Most of the solar system's moons orbit gas giants. While Earth has just one moon and Mars has two tiny ones, the giant planets of the outer solar system are surrounded by sprawling systems of satellites. Jupiter and Saturn each have dozens of confirmed moons, ranging from tiny captured asteroids to massive worlds like Ganymede and Triton. Uranus and Neptune also host many icy moons, some with complex orbits and possibly hidden oceans beneath their frozen surfaces. These gas giants act like miniature solar systems in their own right. Their powerful gravity draws in debris and helps satellites coalesce over time. The farther from the Sun you travel, the more moons you will find. This pattern exists because the outer regions of the solar system contained more material during formation, and the gas giants had enough mass to capture and hold on to numerous satellites. It is a reminder that gravity gathers companions wherever it is strong enough, creating families of worlds in the cold outer reaches. Fact 54. Hubble has photographed planets from Earth orbit. Though it orbits just above Earth's atmosphere, the Hubble Space Telescope has captured detailed images of the outer planets. It has photographed cloud bands swirling across Jupiter, monitored storms raging on Neptune, and tracked seasonal changes on Mars. These images provide long-term observations that complement the data from spacecraft flybys. While probes like Voyager or Cassini visit planets briefly, Hubble can watch them continuously over years and decades. This allows scientists to study evolving weather patterns, monitor impact events, and observe planetary auroras in ultraviolet and visible light. From its quiet position in the low Earth orbit, Hubble watches not only distant galaxies billions of light-years away, but also the shifting faces of our neighbouring worlds. It bridges the gap between Earth-based astronomy and deep space exploration. Fact 55. Jupiter's Great Red Spot is centuries old. The Great Red Spot is a massive storm swirling in Jupiter's southern hemisphere. It is wide enough to swallow 2 or even 3 Earths side by side. This storm has been raging for at least 350 years, and possibly much longer. Astronomers first observed the Great Red Spot in the 1600s through early telescopes. Since then, it has changed over time, gradually shrinking in size but still remaining incredibly powerful. Its reddish hue may be caused by complex chemical reactions in Jupiter's atmosphere, triggered by sunlight interacting with high-altitude compounds. Wind speeds along the outer edges of the storm exceed 400 kilometers per hour. While storms on Earth last for days or weeks at most, this Jovian tempest spans centuries. It is trapped in the planet's turbulent atmospheric belts, a permanent feature of a restless world. Fact 56. Neptune radiates more heat than it receives from the Sun. Although Neptune lies far from the Sun and receives very little sunlight, it is not a frozen, inert world. In fact, Neptune radiates about 2.6 times more energy than it receives from the Sun. This internal heat drives strong winds and storm systems, including the fastest recorded winds in the solar system. The exact source of Neptune's heat remains somewhat uncertain. Possibilities include the residual energy left over from the planet's formation, slow gravitational contraction that releases heat, or radioactive decay within the core. Despite its extreme distance from the Sun, Neptune is a world of surprising energy. The planet has a cold exterior, with cloud-top temperatures plunging to minus 200 degrees Celsius. But beneath those clouds lies warmth and motion. Neptune is a planet with a restless interior, constantly reshaping its windswept atmosphere despite being billions of kilometers from the Sun's warmth. Fact 57. Earth is the only planet with water in all 3 states. Our planet is unique in that water exists naturally on its surface as a solid, liquid, and gas all at the same time. Ice caps and glaciers cover the poles, oceans and lakes spread across continents, and clouds and vapor drift through the atmosphere. This balance is crucial for life and is regulated by Earth's distance from the Sun, its atmospheric pressure, and its relatively stable climate. Other worlds may have water in isolated forms. Europa has an ice crust with a possible liquid ocean below, Mars has ice caps and frost. Titan has methane rain. But none show the same dynamic planet-wide presence of water in all three states. On Earth, water flows through rivers, freezes into snow and evaporates into clouds in a never-ending cycle. This movement sustains ecosystems, shapes landscapes, and drives weather patterns. It is one of the defining characteristics of our blue planet. Fact 58. The heliopause marks the edge of the Sun's influence. As the solar wind flows outward from the Sun, it eventually collides with the interstellar medium, the thin gas and dust that exists between stars. This boundary is called the heliopause, and it defines the outer edge of the Sun's protective bubble, known as the heliosphere. Beyond this point, the pressure from other stars and galactic particles becomes stronger than the outward push of the solar wind. Voyager 1 crossed the heliopause in 2012, followed by Voyager 2 in 2018. Both spacecraft entered true interstellar space, regions where the influence of our Sun fades and the environment of the galaxy takes over. Though the Sun's gravity still extends much farther, reaching out to the distant Oort cloud, the heliopause marks the end of the Sun's energetic reach. It is the final breath of solar influence before the vastness of deep space begins. Fact 59. The solar system is drifting through a local cloud. Our entire solar system is moving through a region of space called the local interstellar cloud. This is a thin concentration of gas and dust about 30 light-years across. It is part of a larger structure known as the local bubble, which was formed by ancient supernova explosions millions of years ago. As the Sun travels through this cloud at about 7,000 kilometers per hour, the heliosphere acts like a shield, deflecting interstellar material away from the planets. Scientists study this cloud to understand how interstellar conditions can affect cosmic rays, the shape of the heliosphere, and even long-term climate patterns on Earth. We are not sitting still in the universe. We are sailing slowly and silently through a galactic fog and surrounded by the faint remnants of ancient stellar explosions. The solar system is always in motion, always passing through new regions of space. Fact C. Some moons are geologically active. Geological activity is not limited to planets alone. Several moons in the solar system show clear signs of internal energy and surface change. Io, orbiting Jupiter, is riddled with active volcanoes fueled by tidal heating. Enceladus, circling Saturn, vents plumes of water vapor into space through cracks in its surface. Europa and Ganymede both likely have subsurface oceans stirred by internal warmth. Even distant Triton, Neptune's captured moon, shows signs of cryovolcanism, where icy material erupts from below driven by shifting pressures and temperatures. These moons are not static ice balls or dead rocks. They are restless worlds with their own geology, chemistry, and possibly even the potential for biology. Beneath their frozen exteriors, some of these moons may harbour conditions suitable for life, hidden from view but still active and dynamic. Fact 61. Pluto's atmosphere comes and goes. Though Pluto is small and incredibly cold, it has the thin atmosphere composed mostly of nitrogen with traces of methane and carbon monoxide. This atmosphere is not permanent. It changes dramatically depending on Pluto's position in its elliptical orbit. When Pluto approaches the Sun during its 248-year orbit, surface ices begin to sublimate, turning directly from solid to gas without melting. This creates a hazy envelope that expands into space. But as Pluto moves farther away from the Sun, the atmosphere cools and collapses. The gases freeze and fall back onto the surface like frost. During the New Horizons flyby in 2015, Pluto's atmosphere was visible as a layered blue haze surrounding the dwarf planet. It was a fleeting breath of warmth around a world that spends most of its existence in deep cosmic winter, frozen and mareless. Fact 6. Temperatures at the Sun's core exceed 15 million degrees. Deep inside the Sun, at its very centre, temperatures soar to over 15 million degrees Celsius. Here, the pressure is so immense that hydrogen atoms are forced together, fusing into helium atoms. This nuclear fusion is what powers the Sun's light and heat, and ultimately all life on Earth. The energy generated in the core takes an incredibly long time to reach the surface. Photons produced by fusion bounce around inside the Sun, scattering through dense layers of plasma. It can take hundreds of thousands of years for a single photon to travel from the core to the surface. Once the energy finally escapes, it crosses the vacuum of space in just over 8 minutes to reach Earth. The Sun's radiant calm hides an unimaginably hot and violent heart, where temperatures and pressures create the very light that warms our world. Fact 63. Uranus has a faint tilted ring system. Though Saturn's rings are the most iconic, Uranus also has a ring system. It consists of 13 known rings, though they are much darker and fainter than Saturn's brilliant bands. These rings are made of tiny particles of rock and ice, and they orbit in an alignment with Uranus's unusual tilt. Since the planet lies almost on its side, the rings appear vertical when viewed from above the Sun's north pole. Some of the rings are narrow and sharp-edged, possibly shaped by small shepherd moons that help maintain their structure. The rings were not discovered until 1977, when they blocked the light of a background star during an observation. They are subtle, shadowy bands circling a sideways planet. They lack the grandeur of Saturn's rings, but they add to the mystery and uniqueness of this distant ice giant. Fact 64. The heliosphere is a magnetic bubble blown by the Sun. The solar wind, a constant stream of charged particles released by the Sun, flows outward in all directions. As it travels through space, it creates a vast magnetic bubble that surrounds the entire solar system. This structure is called the heliosphere, and it acts like a shield against galactic radiation. The heliosphere is shaped by solar activity and by the pressure of the interstellar medium pushing back against it. It stretches far beyond Pluto, enclosing all the planets, comets, and distant objects in a protective cocoon. Its outer edge, the heliopause, is where the solar wind's influence ends and interstellar space begins. As the Sun orbits the Milky Way, the heliosphere moves with it, protecting the solar system as it drifts through changing regions of interstellar space. It is an invisible barrier that has shielded Earth for billions of years. Fact 65. Mercury's orbit helped prove Einstein's theory of gravity. For centuries, astronomers noticed something strange about Mercury's orbit. Its closest approach to the Sun, called perihelion, slowly shifted over time. This shift, known as precession, occurred more than Newtonian physics could account for. The discrepancy was small, but it was measurable and unexplained. In 1915, Albert Einstein's theory of general relativity provided the solution. According to the relativity, massive objects like the Sun warp the fabric of space-time itself. This warping subtly alters planetary paths in ways that Newton's laws cannot predict. The small but measurable effect on Mercury's orbit matched Einstein's predictions exactly. This became one of the first experimental confirmations of Einstein's revolutionary theory. It was a triumph of mathematics and observation, using the motion of a scorched rocky world to validate a new understanding of gravity and space-time. Fact 66. The Moon shapes Earth's tides. The daily rise and fall of ocean tides on Earth are largely caused by the gravitational pull of the Moon. As the Moon orbits our planet, its gravity tugs on Earth's oceans, creating bulges on the side facing the Moon and on the opposite side as well. As Earth rotates beneath these bulges, different coastlines experience high and low tides. The Sun also influences tides, and when the Sun and Moon align, their combined gravity creates especially high spring tides. When they are at right angles, the result is smaller neap tides. Tidal forces not only affect the oceans, they can also subtly shift the Earth's crust and even influence the planet's rotation. The Moon's silent pull keeps the oceans in constant motion, a rhythmic rise and fall that has shaped coastlines and influenced life for billions of years. Fact 67. There may be undiscovered planets beyond Neptune. Astronomers have noticed that some distant objects in the Kuiper Belt follow clustered, elongated orbits that are difficult to explain using only the known planets. One leading theory is that a large, as yet undetected planet may be influencing these distant paths with its gravity. This hypothetical world is sometimes called Planet 9. If it exists, it would be several times the mass of Earth and would orbit far beyond Pluto, taking thousands of years to complete a single revolution around the Sun. No direct evidence has confirmed its existence yet, but telescopes continue searching the outer solar system. If Planet 9 is found, it would reshape our understanding of the solar system's outer architecture. It would be a hidden giant lurking in the darkness, exerting influence from afar without ever being seen. Fact 68. Callisto may have an ocean. Beneath its icy surface, Jupiter's moon. Callisto appears quiet and heavily cratered, with an ancient surface that shows little sign of recent geological activity. But beneath that frozen exterior, scientists suspect a subsurface ocean may exist, similar to those believed to lie beneath Europa and Ganymede. Magnetic readings from the Galileo spacecraft hinted at a conductive layer beneath Callisto's surface, which is consistent with the presence of salty liquid water. If confirmed, Callisto would join the growing list of ocean worlds in the outer solar system. Though less well known than Europa, Callisto's deep, dark sea could contain the ingredients necessary for life. It would be silently sealed beneath a shell of ancient ice and cratered rock, hidden from view but potentially rich with possibility. Fact 69. Venus is hotter than Mercury, despite being farther from the Sun. Although Mercury is the closest planet to the Sun, Venus holds the record for the hottest surface temperatures in the solar system. Venus's surface temperature exceeds 460 degrees Celsius, hot enough to melt lead and vaporize many metals. This extreme heat is due to Venus's incredibly thick atmosphere, which is composed mostly of carbon dioxide. The atmosphere traps heat in a runaway greenhouse effect, preventing warmth from escaping back into space. The dense clouds that surround Venus reflect sunlight, but they also act like a thermal blanket. Meanwhile, Mercury has only a thin exosphere and no real atmosphere to retain heat. Its surface temperature swings wildly between day and night. Venus's searing heat is not just about proximity to the Sun. It is about the power of atmospheric insulation and the devastating effects of trapped radiation. Facts of 70. The rings of Saturn are made mostly of ice. Though they shimmer and glow like solid bands of light, Saturn's rings are composed of countless individual particles. These particles are mostly water ice, ranging in size from tiny grains of dust to chunks the size of houses or even small buildings. The ice gives the rings their brilliant reflectivity, making them one of the brightest features in the solar system when viewed from a distance. The particles orbit Saturn in an incredibly thin, flat disk, held in place by gravity and the fool's subtle influence of nearby moons. Embedded within the rings are narrow gaps, wave patterns, and faint ringlets shaped by gravitational resonances with Saturn's satellites. The rings are not static. They are dynamic, ever-changing structures made of countless fragments of ice caught in endless motion around the giant planet. Fact 71. Ceres is both an asteroid and a dwarf planet. Located in the asteroid belt between Mars and Jupiter, Ceres is the largest object in that crowded region. It is so large, in fact, that it qualifies as a dwarf planet rather than just an ordinary asteroid. Ceres was discovered in 1801, making it one of the first asteroids ever identified. Unlike smaller asteroids, Ceres is spherical, shaped by its own gravity into a round form. Scientists believe it may contain a subsurface layer of briny water or salty mud beneath its rocky crust. NASA's Dawn spacecraft revealed mysterious bright spots on the surface, which turned out to be deposits of salt, possibly left behind by evaporating water. Ceres is a hybrid world, neither quite a planet nor a typical asteroid. It offers a glimpse into the early ingredients of planetary formation, a fossil from the solar system's infancy preserved in the asteroid belt. Fact 72. Mars appears red because of rust. The surface of Mars is coated in a fine layer of dust made primarily of iron oxide, the same compound that gives rust its distinctive reddish colour. Over billions of years, this iron-rich material has rusted in the thin Martian atmosphere, creating the planet's signature rusty hue. The dust is so pervasive that it colours the sky during storms and coats nearly the entire surface of the planet. Despite this rusty appearance, Mars also has dark basaltic plains, ancient lava flows, and polar ice caps made of water and frozen carbon dioxide. These features create subtle colour variations across the landscape, but from a distance the distinctive reddish tone dominates everything. Mars glows with a warm, rusty light in the night sky. Dusty signal of oxidation on a cold desert world that once may have been wetter and warmer. Fact 73. Sunspots are cooler regions on the Sun's surface. Though the sun's surface blazes at thousands of degrees, some areas appear darker than their surroundings. These darker regions are called sunspots, and they are not actually cold. They are simply cooler than the rest of the photosphere. Sunspots form where intense magnetic activity suppresses the outward flow of heat from the sun's interior. This creates temporary regions that are a few thousand degrees cooler than their surroundings. Because of the contrast, they appear dark against the bright surface. Sunspots can be larger than Earth and often appear in pairs or clusters. They follow an 11-year cycle, becoming more numerous and active as the sun approaches solar maximum. Despite their name, sunspots are still extremely hot. They are magnetic scars on the sun's surface, revealing the constantly shifting internal dynamics of our star. Fact 74. Uranus was discovered by telescope. Unlike the planets known since ancient times, which are visible to the naked eye, Uranus was not officially identified until 1781. Astronomer William Herschel observed it through a telescope and at first thought it might be a comet or a distant star. Further observations confirmed that it was moving in a planetary orbit, making Uranus the first planet discovered in modern times. This discovery expanded the known boundaries of the solar system and marked a turning point in astronomy, shifting from naked-eye observation to instrument-based exploration. Since then, Uranus has revealed many surprises through telescopic and spacecraft observation. Its extreme axial tilt, its faint rings, and its collection of icy moons have all added to our understanding of this distant ice giant. It is a planet that quietly rewrote the map of the solar system. Fact 75. The solar system is about 4.6 billion years old. By studying ancient meteorites, radioactive isotopes, and the oldest rocks found on Earth and the Moon, scientists have traced the age of the solar system to approximately 4.6 billion years. It all began as a swirling cloud of gas and dust known as the solar nebula. This nebula collapsed under its own gravity, forming the Sun at its centre. The remaining material spread out into a rotating disk, where it gradually coalesced into planets, moons, asteroids, and comets. This process of accretion and differentiation laid the foundation for everything that exists in the solar system today. The planets we see now are survivors of a chaotic beginning, shaped by countless collisions, migrations, and slow cooling over billions of years. The solar system is ancient, but it is still young compared to the age of the universe itself. Fact 76. Vesta has a layered structure. Like a planet Vesta, the second largest object in the asteroid belt is not just a simple rock floating through space. It is actually a protoplanet with a differentiated internal structure. Beneath its battered surface lies a mantle and a dense metallic core, similar to the layered structure found in Earth and other terrestrial planets. This remarkable internal organization means that Vesta once had enough heat inside to melt and separate into distinct layers. Heavier materials like iron sank toward the center, while lighter rocky materials rose to form the outer layers. This process, called planetary differentiation, typically only happens in bodies large enough to generate significant internal heat through radioactive decay and gravitational compression. The giant impact that carved out the Rhea Silvia crater at Vesta's south pole may have exposed some of these deeper internal layers, giving scientists a rare glimpse into the interior composition of a protoplanet. Vesta is essentially a frozen fossil, a planetary building block that never quite made it to full planet status. It remains suspended in time, preserving evidence of processes that shaped the rocky planets billions of years ago. Fact 7. The Moon has quakes. Though it appears still and unchanging in the night sky, the Moon occasionally trembles with moonquakes. These seismic events can be caused by several different mechanisms. Some are triggered by tidal forces from Earth's gravity, which continue to flex and stress the lunar interior even though the Moon is solid rock. Other moonquakes result from thermal expansion and contraction. As the lunar surface heats dramatically during the long day, and then plunges into freezing temperatures during the equally long night, the rocks expand and contract. This repeated heating and cooling creates stress fractures that can suddenly release, producing tremors. Some moonquakes originate deep within the Moon's interior, and can last for up to an hour, or far longer than typical earthquakes on Earth. Data collected from seismometers placed on the lunar surface during the Apollo missions first revealed these subtle shakes. New instruments continue to study them, helping scientists understand the Moon's internal structure. Though the Moon has no tectonic plates and no active volcanoes, Its interior is not entirely dormant. It has a quiet, pulsing rhythm beneath its ancient, cratered surface. Fact 78. Triton is a captured moon. Neptune's largest moon, Triton, stands out among all the major moons in the solar system because it orbits in the opposite direction of its planet's rotation. This backward, retrograde orbit is highly unusual for such a large satellite and provides strong evidence that Triton did not form alongside Neptune. Instead, scientists believe Triton was once an independent object, probably similar to Pluto, that was captured from the Kuiper Belt billions of years ago. When Neptune's gravity snared Triton and pulled it into orbit, the capture event was likely violent and chaotic. The gravitational disruption may have destroyed or scattered Neptune's original moon system, leaving Triton as the dominant satellite. The capture also tilted and heated Triton's interior through intense tidal forces. Today, Triton remains geologically active despite the frigid temperatures at its distance from the Sun. Geysers erupt from its surface, shooting nitrogen gas and dark material high into the thin atmosphere. The surface is marked by strange cantaloupe-like textures, fractured terrains, and bright patches of frozen nitrogen. Triton is both a relic of the outer solar system and a moon fundamentally shaped by its violent adoption into Neptune's family. Fact 79. Neptune has 14 known moons. Neptune, the farthest major planet from the Sun, is orbited by at least 14 known moons. These satellites range dramatically in size and character. The largest, Triton, dominates the system and accounts for most of the total mass. But beyond Triton lies a collection of smaller, irregular moons with names like Proteus, Nereid, Larissa, and Galatea. Many of these smaller moons follow eccentric orbits, and some are likely captured objects from the Kuiper Belt rather than bodies that formed alongside Neptune. Others may have originated from collisions or from debris left over after Triton's capture disrupted the original satellite system. Most of these moons are icy and extremely dark, reflecting very little of the faint sunlight that reaches them. Their varied orbits and compositions offer valuable clues about Neptune's violent past and the possible migrations of planets during the solar system's early development. Together, these 14 moons form a scattered family of companions around a planet that drifts eternally on the cold, dark edge of the known solar system. Fact 80. The Parker Solar Probe is touching the Sun. Launched into 2018, NASA's Parker Solar Probe represents one of the most audacious missions in the history of space exploration. It is the first spacecraft designed to fly directly through the Sun's outer atmosphere, a region known as the corona that extends millions of kilometers from the solar surface. The probe moves at extraordinary speeds, faster than any human-made object ever built, reaching velocities that exceed 700,000 kilometers per hour at its closest approaches. Despite travelling through regions where temperatures soar above 1,000 degrees Celsius, the spacecraft survives thanks to a revolutionary carbon composite heat shielder that faces the Sun constantly, protecting the instruments behind it. With each orbit, the probe dips closer to the Sun, gathering unprecedented data on solar wind behaviour, magnetic field structures, and the acceleration of energetic particles. Its mission aims to solve long-standing mysteries such as why the corona is hundreds of times hotter than the visible surface below it, and how solar flares gain their tremendous energy. In a very real sense, the Parker Solar Probe is not just studying the Sun from a distance, it is flying through it, touching the star that gives us life. Fact 81. Some meteorites on Earth came from Mars. Though Mars is millions of kilometers away across the void of space, pieces of the red planet have actually landed here on Earth. These are Martian meteorites, fragments of rock that were blasted off the Martian surface by powerful asteroid or comet impacts. The force of these collisions was so great that chunks of the planet were ejected into space at speeds high enough to escape Mars's gravity. These rocky fragments then travelled through the solar system for thousands or even millions of years before their orbits eventually intersected with Earth. When they entered our atmosphere, they fell as meteorites. Scientists can identify them as Martian in origin by comparing their chemical composition and mineralogy to data collected by Mars rovers and orbital spacecraft. Some of these meteorites contain tiny bubbles of trapped Martian atmosphere, preserving actual samples of the air from another world. Others show minerals that were clearly shaped by the presence of liquid water, offering direct physical evidence of Mars's wetter past. These wayward sions are natural samples from another planet, delivered to us by cosmic chance long before any spacecraft successfully returned material from Mars. Fact 82. The Sun is mostly hydrogen and helium. About 70% of the Sun's total mass consists of hydrogen, the lightest and most abundant element in the universe. Most of the remaining mass is helium, the second lightest element. Together, these two gases make up roughly 98% of everything the Sun contains. These elements are the fundamental fuel for the nuclear fusion reactions happening continuously in the Sun's core. Under the extreme pressure and temperature conditions deep inside, hydrogen nuclei are forced together until they fuse into helium, releasing tremendous amounts of energy in the process. This energy is what makes the Sun shine and provides warmth and light to the entire solar system. The remaining 1–2% of the Sun's mass includes heavier elements like oxygen, carbon, nitrogen, iron, and many others. These heavier elements were not created in the Sun itself, but originated in earlier generations of stars that lived and died before our solar system formed. Despite the Sun's brilliance, complexity, and power, it is fundamentally quite simple in composition. It is a glowing sphere of primordial gases, shaped and sustained by the gravity and nuclear fire. Fact 83. Earth's tilt gives us seasons. Earth's axis is tilted approximately 23.5 degrees relative to the plane of its orbit around the Sun. This seemingly small tilt is the fundamental reason we experience seasons. As Earth travels around the Sun over the course of a year, different hemispheres tilt toward or away from the Sun at different times. When the northern hemisphere tilts toward the Sun, it receives more direct sunlight and experiences longer days. This creates summer in the north, while the southern hemisphere, tilted away, experiences winter. 6 months later, the situation reverses. Without this axial tilt, there would be almost no seasonal variation. Most regions would experience relatively constant temperatures year-round, and the climate patterns that shape ecosystems and weather would be dramatically different. The tilt itself has shifted slightly over tens of thousands of years due to gravitational influences from the Moon and other planets. These long-term wobbles and variations in Earth's orbit are believed to influence ice ages and other major climate shifts. The tilt is one of the quiet architects of life's seasonal rhythms, shaping migrations, harvests, and the natural cycles that have governed life on Earth for billions of years. Fact 84. Jupiter's magnetosphere is the largest structure in the solar system. Jupiter generates an immense magnetic field, the most powerful of any planet. This field extends millions of kilometers into space, forming a magnetosphere so vast that if it were visible to the human eye, it would appear larger than the full moon in Earth's night sky, despite Jupiter being hundreds of millions of kilometers away. This enormous magnetic bubble is powered by electric currents flowing through Jupiter's interior. Deep inside the planet, beneath the visible cloud layers, hydrogen exists under such extreme pressure that it behaves like a liquid metal. The motion of this metallic hydrogen as Jupiter spins creates powerful electric currents, which in turn generate the planet's magnetic field through a dynamo effect. Within this magnetosphere, charged particles are trapped and accelerated along magnetic field lines, creating zones of intense radiation. These radiation belts are so powerful they pose serious hazards to spacecraft and would be lethal to unprotected astronauts. The magnetosphere also captures particles ejected by volcanoes on Io, creating glowing auroras and electrical storms near Jupiter's poles. For scientists studying planetary magnetism, Jupiter represents nature's most extreme laboratory. Fact 85. Planetary rings may be temporary. Though planetary rings appear majestic and permanent when we observe them through telescopes, they may actually be relatively short-lived features on cosmic timescales. Rings form from various sources, including shattered moons broken apart by tidal forces, leftover debris from the planet's formation, or icy particles pulled into orbit after collisions. However, over millions of years, the material in rings tends to spiral inward. Gravity pulls particles toward the planet, magnetic fields can drag charged material downward, and collisions between ring particles cause them to lose energy and fall inward. Observations from spacecraft like Cassini suggest that Saturn's spectacular rings may be less than 100 million years old, which is young compared to the age of the solar system itself. The same observations indicate the rings could vanish entirely within another 100 million years. The rings around Jupiter, Uranus and Neptune appear even more ephemeral and may be constantly replenished by material knocked off and nearby moons. The rings we see today represent a fleeting phase, a spectacular shimmering moment in a planet's much longer existence. Future civilizations, if any arise, might look at these worlds and see only bare planets stripped of their glorious adornments. Fact 86. The moon's surface barely changes over time. Without wind, rain, flowing water, or active geological processes, the lunar surface remains almost entirely unchanged for millions or even billions of years. The famous footprints left by Apollo astronauts in the fine lunar dust will likely remain preserved and visible for thousands of generations, slowly degrading only through the subtle effects of micrometeorite impacts and radiation exposure. The primary forces that shape the moon's surface today are micrometeorites, tiny particles that constantly bombard the surface at high speeds, and cosmic radiation from the sun and deep space. These processes cause a gradual erosion known as space weathering, which very slowly breaks down rocks and alters the properties of the surface material. Impact craters from ancient collisions still dominate the lunar landscape, creating a detailed record of bombardment going back billions of years to the solar system's violent youth. Some of these craters are so old they formed when life on Earth was just beginning. The moon is not only Earth's closest neighbour in space, it is also one of the most faithful and enduring geological archives we have access to, preserving history that has long since been erased from Earth's constantly changing surface. Fact 87. Some icy moons may have hydrothermal vents. Beneath the thick ice crusts of moons like Europa and Enceladus, scientists believe vast subsurface oceans exist in complete darkness, but these oceans may not be entirely cold and lifeless. Evidence suggests that in some places, the liquid water may be in contact with hot rocky cores below, creating conditions similar to hydrothermal vents found on Earth's ocean floors. On our own planet, hydrothermal vents support thriving ecosystems that exist completely independent of sunlight. These underwater communities are powered by chemical energy derived from minerals and heated water seeping up from Earth's interior. Microorganisms use this chemical energy to produce organic compounds, forming the base of a food chain that includes tube worms, crustaceans, and other specialized creatures. If similar vents exist on Europa, Enceladus, or other ocean moons, they could provide all the necessary ingredients for life, including liquid water, heat, and a steady source of chemical energy. Plumes erupting from Enceladus have been found to contain organic compounds and other chemicals associated with biological processes. These hidden underwater worlds, sealed beneath kilometers of ice and far from the sun's light, may represent some of the most promising places in the solar system to search for extraterrestrial life. Fact 88. Sunlight takes over 8 minutes to reach Earth. The light that warms your skin on a sunny day and brightens the sky above began its journey deep within the sun's core. There, nuclear fusion creates photons, particles of light and energy. But these photons do not immediately escape. They must first navigate through the incredibly dense interior of the sun, bouncing and scattering through layer after layer of hot plasma. This journey from the core to the surface can take hundreds of thousands of years. The photons are absorbed and re-emitted countless times, slowly working their way outward through the sun's convective and radiative zones. Only when they finally reach the photosphere, the visible surface, can they escape into space. Once free of the sun, however, the photons travel at the speed of light through the vacuum of space, covering the distance to Earth in just over 8 minutes. This means that when you watch a sunrise or look at the midday sun, you are seeing it not as it is in that exact moment, but as it was 8 minutes ago. You are looking into the very recent past, witnessing light that left the sun before you finished your morning coffee. Fact 89. Europa's cracked ice may shift like tectonic plates. The surface of Jupiter's moon. Europa is covered in a thick shell of frozen water, but this ice is far from smooth or uniform. It is crisscrossed with dark reddish-brown lines, long ridges, and regions of chaotic jumbled terrain that look like broken puzzle pieces pushed together and pulled apart. These strange surface features strongly suggest that Europa's icy shell is moving, breaking, sliding, and possibly even subducting in a manner similar to Earth's tectonic plates. If this is true, Europa would be the only known body besides Earth with active plate-like motion. The process could be driven by the tidal flexing from Jupiter's gravity, which constantly kneads and deforms the moon's interior, creating heat and motion. This potential ice tectonics could be extremely important for habitability. Moving ice could help cycle nutrients between the surface and the hidden ocean below, distributing chemical compounds that might support life. The cracks and fissures could also provide pathways for water to reach the surface or for surface material to sink downward. Europa is a frozen world, but it is definitely not a static one. Its surface tells a story of motion, change and dynamic processes driven by the powerful gravitational grip of Jupiter. Fact 90. Saturn is less dense than water. If you could somehow find a bathtub large enough to hold Saturn, the giant planet would actually float. This is because Saturn's average density is less than that of liquid water. While this seems impossible for such a massive object, it is entirely due to the planet's composition and structure. Saturn is made mostly of hydrogen and helium, the two lightest elements in the universe. These gases give the planet an overall lightness despite its enormous volume. Saturn's volume is more than 700 times greater than Earth's, but its mass is only about 95 times greater. This means the material is spread out and diffuse rather than packed tightly together. Saturn's low density also contributes to its distinctive shape. The planet's rapid rotation, completing one spin in just over 10 hours, causes it to bulge significantly at the equator and flatten at the poles. The combination of low density and fast rotation creates a planet that looks slightly squashed, like a ball that has been gently compressed from above and below. Saturn is a giant puffed softly into shape by gravity and motion. Fact 91. Solar flares can disrupt technology on Earth. Solar flares are sudden, violent eruptions of energy from the sun's surface, often linked to the complex magnetic activity associated with sunspots. These outbursts release intense bursts of radiation across the entire electromagnetic spectrum, from radio waves to X-rays and gamma rays, all within a matter of minutes. When a particularly powerful flare is directed toward Earth, the radiation reaches our planet in about 8 minutes, travelling at the speed of light. This burst of energy can disturb the upper layers of Earth's atmosphere, particularly the ionosphere, which plays a crucial role in radio communications. The disruption can affect GPS satellite signals, interfere with radio transmissions, and cause temporary blackouts in communication systems. In extreme cases, solar flares can be accompanied by coronal mass ejections, massive clouds of charged particles that take 1 to 3 days to reach Earth. When these particles interact with our planet's magnetic field, they can trigger powerful geomagnetic storms. These storms have the potential to damage power grids, disable satellites, and even cause widespread electrical blackouts. While Earth's magnetic field provides significant protection, solar flares remind us that the sun is not a steady, predictable light source. It is a dynamic and occasionally volatile star that can send ripples of disruption across the entire solar system. Fact 92. The solar cycle influences auroras, those shimmering curtains of green, red, violet, and sometimes blue light that dance near Earth's polar regions, are caused by charged particles from the sun interacting with our planet's magnetic field and atmosphere. When these particles spiral down magnetic field lines toward the poles, they collide with oxygen and nitrogen molecules in the upper atmosphere, causing them to glow with characteristic colours. The frequency and intensity of auroras are directly connected to the sun's 11-year magnetic cycle. During periods of high solar activity, known as solar maximum, increased sunspot activity and more frequent solar flares send greater numbers of charged particles streaming toward Earth. This results in more frequent and more spectacular auroral displays that can sometimes be seen at lower latitudes than usual. During solar minimum, when the sun is quieter and less active, auroras become less common and generally remain confined to regions closer to the poles. The connection between solar activity and auroras demonstrates how the sun's magnetic fluctuations ripple outward through space, painting the skies of Earth with subtle solar brushstrokes. These lights are visible evidence of space weather, a reminder that we live within the sun's extended atmosphere. Fact 93. Comet tails always point away from the sun. As a comet approaches the inner solar system from the cold outer reaches, the sun's heat causes the icy surface to sublimate, transforming directly from solid ice to gas without melting. This released material forms a glowing envelope around the comet's nucleus and eventually streams away to form a tail. But contrary to what intuition might suggest, the tail does not trail behind the comet, like smoke behind a moving train. Instead, it always points away from the sun, regardless of which direction the comet is actually travelling. This happens because the tail is shaped not by the comet's motion, but by the pressure of solar wind and solar radiation pushing the material outward. Most comets actually develop two distinct tails. The dust tail, made of heavier particles, curves gently and appears yellowish or white because it reflects sunlight. The ion tail, composed of charged gas molecules, is pushed more directly by the solar wind and appears straight and bluish. These tails can stretch for millions of kilometers through space, creating luminous windswept signatures that trace the invisible force of sunlight and solar particles pushing through the darkness. Fact 94. Some planetary moons formed from giant impacts. Earth's moon is widely believed to have formed from a catastrophic collision between the young Earth and a Mars-sized body about 4.5 billion years ago. This impact, sometimes called the Big Whack or the Theia impact, was so violent that it ejected enormous amounts of molten and vaporized material into orbit around Earth. Over time, this debris cloud gradually cooled and coalesced, eventually forming the moon we see today. Similar impact origins are suspected for other moons in the solar system. Pluto's large moon, Charon, for example, may have formed from a collision that was proportionally even more significant than the one that created Earth's moon. These violent birth stories contrast sharply with the captured moons of the outer planets, which were likely independent objects snared by planetary gravity. The diversity in how moons formed reflects the chaos and creativity of the solar system's early years. Some moons were born from fire and collision, forged in the aftermath of planetary catastrophes. Others were gently captured from passing debris. Still others formed alongside their host planets from the same cloud of material. Each formation pathway tells a different story about the dynamic processes that shape the solar system. Fact 95. Voyager 1 carries a golden record into deep space. Launched in 1977, Voyager 1 has now travelled farther from Earth than any other human-made object ever created. It crossed the boundary into interstellar space in 2012, becoming the first spacecraft to leave the protective bubble of the Sun's influence. It continues its solitary journey outward through the space between stars, moving at approximately 61,000 kilometers per hour relative to the Sun, never slowing, never stopping. Attached to the spacecraft's exterior is a remarkable artifact, a 12-inch golden phonograph record that serves as a time capsule containing sounds and images, carefully chosen to represent the diversity of life and culture onto Earth. This is not simply a collection of random data. It is humanity's attempt to speak across the void, to say something meaningful about who we are and what our world contains. The record includes greetings spoken in 55 different languages, from ancient tongues to modern dialects, each voice saying hello in its own unique way. There is a selection of music representing various cultures and historical periods, including everything from Bach and Beethoven to traditional folk songs from around the world, from ceremonial chants to jazz performances. The record also contains natural sounds that capture the essence of Earth, the crash of ocean waves against shorelines, the songs of humpback whales echoing through deep water, the calls of birds at dawn, wind rustling through trees, the rhythm of human heartbeats, and the sound of a mother's kiss and a child's laughter. The Golden Record was designed by a committee chaired by the famous astronomer and science communicator Carl Sagan, who understood that this might be humanity's only chance to send a message beyond the solar system. The record is encased in a protective aluminum jacket, and the cover is engraved with instructions for how to play it, rendered in symbolic form that does not rely on any human language. The cover also includes a map showing Earth's location in the galaxy using the positions of pulsars as reference points, along with diagrams explaining our Sun's position relative to the centre of the Milky Way. The record is meant for any intelligent beings who might someday encounter the spacecraft as it drifts silently through the vast distances between stars. The odds of discovery are vanishingly small. Space is unimaginably vast, and Voyager is a tiny speck moving through an ocean of darkness. It will take more than 40,000 years just to pass anywhere near another star system, yet the Golden Record persists. A message in a bottle cast into the cosmic ocean, a quiet greeting from our small, fragile blue world to whatever else might exist out there into the infinite darkness and silence. Fact 96. Earth shares its orbit with co-orbital asteroids. Although Earth follows its own distinct path around the Sun, it does not travel entirely alone. The region of space near Earth's orbit is shared with small rocky bodies known as co-orbital asteroids. These objects do not orbit Earth itself like moons. Instead, they follow complex looping paths near Earth's orbit, shaped by the combined gravitational influences of the Sun and Earth. Some of these asteroids, called Trojans, hover near stable gravitational balance points known as Lagrange points. These points exist ahead of and behind Earth along its orbital path there, creating regions where the gravitational forces are balanced in such a way that objects can remain relatively stable. Other co-orbital asteroids follow horseshoe-shaped orbits, appearing to slowly approach Earth, then loop around and move away again in a repeating pattern. These quiet companions are often temporary, captured and released over periods of thousands to millions of years as their orbits gradually shift. They are too small and faint to be visible to the naked eye, but they drift near us in space, fellow travellers on our yearly journey around the Sun. Their existence demonstrates that even a planet's orbit is not a simple isolated path, but rather a region of space populated by numerous smaller bodies caught in gravitational dances. Fact 97. Neptune was once confused with Uranus. Before Neptune was officially discovered in 1846, some early astronomers may have observed it without realizing what they were looking at. Because Neptune moves very slowly across the sky and appears extremely dim, it was occasionally mistaken for a fixed star or confused with observations of Uranus. Historical records suggest that the famous astronomer Galileo Galilei may have unknowingly observed Neptune through his telescope as early as 1612. He made notes and drawings of the positions of objects near Jupiter, and later analysis suggests one of the points he marked may have been Neptune. However, Galileo apparently assumed it was simply a background star and did not recognize it as a planet. It was not until mathematicians in the 1840s noticed irregularities in the orbit of Uranus that Neptune's existence was predicted through calculations. When telescopes were finally pointed to the predicted location, Neptune was found exactly where the mathematics suggested it would be. For centuries, this distant ice giant remained hidden in plain sight, its true nature concealed by its faintness and slow motion against the backdrop of stars. Fact 98. The edge of the solar system is not defined by gravity. The Sun's gravitational influence extends extraordinarily far into space, reaching out to the distant Oort cloud where comets drift in the cold darkness nearly a light year away. But when scientists discuss the edge of the solar system, they often refer not to the limit of gravity, but to the boundary of the heliosphere. The heliosphere is the region of space dominated by the solar wind, a constant stream of charged particles flowing outward from the Sun. This region extends far beyond the orbits of all the planets. But eventually the solar wind runs into the interstellar medium, the thin gas and dust that exists between stars. The boundary where these two regions meet is called the heliopause. At the heliopause, the outward pressure of the solar wind is balanced by the inward pressure of the interstellar medium. Beyond this boundary, the Sun's magnetic field and particle flow end, and the environment transitions to true interstellar space. Gravity continues to operate far beyond this point, holding distant comets in wide orbits, but the energetic boundary represents a more immediate transition. It is a subtle, shifting frontier where the space between stars begins, marked more by a change in particle pressure and magnetic environment than by gravity itself. Factor 99. Planetary atmospheres slowly leak into space. Even thick atmospheres like the Earth's are not permanent fixtures. Over vast periods of time, light gases like hydrogen and helium can escape a planet's gravitational pull and drift off into space, lost forever to the void. This process, known as atmospheric escape, occurs continuously but at different rates depending on various factors. Atmospheric escape is more pronounced on smaller planets and moons with weaker gravity, such as Mars, Mercury, and Triton. These worlds cannot hold on to their lighter atmospheric components as effectively as larger planets can. On Venus, which lacks a protective magnetic field, the solar wind has been able to erode parts of the upper atmosphere over billions of years, stripping away lighter elements. Earth loses thousands of tons of hydrogen each year through atmospheric escape, but this loss is easily replenished by various processes, including volcanic outgassing and the breakdown of water molecules in the upper atmosphere. Over geological time, however, this slow leak into the void represents a constant exchange between planets and the vacuum of space. It is a reminder that planetary atmospheres are dynamic, ever-changing envelopes that are continuously being added to and subtracted from through various processes. Fact 100. Some moons may have formed from ring systems. Just as ring systems can decay over time and eventually vanish as material spirals into the host planet, they can also give birth to moons under the right circumstances. In Saturn's system, it is possible that some of the smaller outer moons originally coalesced from ring material that clumped together beyond the Roche limit. The Roche limit is the boundary around a planet where tidal forces become strong enough to tear apart objects held together only by their own gravity. Inside this boundary, material tends to remain as rings, but beyond it, particles can gravitationally attract each other and gradually accumulate into larger bodies, eventually forming moons. Some of Saturn's small inner moons, like Pan and Daphnis, orbit within the rings themselves and may still be accreting material from their surroundings. These moonlets act as quiet sculptors, their gravity carving gaps and waves into the icy bands around them. They represent an intermediate stage between ring particles and full-fledged moons, showing how one structure can gradually transform into another over millions of years. The relationship between rings and moons demonstrates the dynamic, ever-changing nature of planetary systems, where material constantly cycles between different forms and configurations.